In this video, I'm going to work examples having to do with finding the image due to a lens. Here is my first example. I have an image that is, I want to know where the image is. If I have a 3 centimeter focal length concave lens and the object is 2 centimeters from it, I also want to know what is its magnification, and I need to describe it. First things first, I look and say, hey, concave lens. By my sign conventions, that means that my focal length is negative. So the focal length is a negative 3 centimeters. The object distance is 2 centimeters. To find the image, I can use this formula, which is a variation on the other formula that looks like 1 over f equals 1 over do plus 1 over di. And now I just need to plug in numbers. 2 times 3, 2 times negative 3, over 2 minus negative 3. 2 times negative 3 is negative 6. 2 minus negative 3 is 5. And I can rewrite that in terms of a decimal as negative 1.2. Units is centimeters. To find the magnification, I take the image distance divided by the object distance, and there's a negative sign out in front. So I have negative 1.2 divided by 2 is a positive 0.6. Okay, so first off, di is negative. That means it's a virtual image. M is positive. That means it's upright, as all virtual images are. And the absolute value of M, even though it is a positive number here, let's deal with it as an absolute value, is less than 1. That means it is smaller or diminished. For example 2, it's the same setup, but instead of a concave lens, I have a convex lens. Because it's a convex lens, that means that f is greater than 0. do is 2 centimeters. F is a positive 3 centimeters. Using the same formula as I did on the last slide, do times f divided by do minus f, that's 2 times positive 3 over 2 minus 3, which is 6 over negative 1, or negative 6. Units are centimeters. The magnification is negative of the image distance divided by the object distance. So that's negative 6 divided by 2, or positive 3. Okay, so I'm in a similar boat. di is less than 0, meaning it's negative. Therefore, it's a virtual image. The M is greater than 0. That means it's upright, as all virtual images are. And the absolute value of M is greater than 1, which means it's larger. In my last example, I have a unknown lens. I'm told it's convex and that the object is 5 centimeters away, the image is 6 centimeters away, and I should assume that it's real. So do is 5 centimeters. di is going to be a plus 6 centimeters because it's real. And to find the focal length, I have to use that 1 over f equals 1 over the object distance plus 1 over the image distance. So that's 1/5 plus 1/6. If you put that into a calculator, you get 0.367. Units currently are 1 over centimeters. To find the focal length, I have to invert this, and that gives out an answer of 2.73 centimeters.